So tonight we have Mooneer Salem, right?
Yep.
And he's going to talk about SDRs, right?
Mm-hmm.
And so we're excited to hear about that. I know that I played with a little bit of the SDR stick thing, but beyond that, not too much. So
Yeah.
I'm very interested to hear what you have to say.
All right.
Thank you for coming by.
No worries.
Yeah.
Guys, can you hear me okay? All right. So, as you heard, I'm Mooneer, K6AQ. I'm going to talk to you guys a little bit about SDRs. I'm just not really going to be technical. It's more going to be a big general overview of SDRs and my experience with a few of them. That's pretty much what we're going to go with. So, just a little bit about myself. I'm licensed since the early 2000s. My original call sign was K6AQ. I did the whole thing where you're basically getting the hobby like intensely to start, and then kind of just stop doing it for a while. I don't know how common of a theme that is with you guys. And then basically went to college, spent a few years after college, and then finally got my own place, got my camp setup back, and I decided I wanted to go upgrade to extra. I decided I wanted to upgrade to general, then I ended up upgrading to extra, and now we're here. My day job, I was talking to a couple people already about it. Basically, work for a medical device company, mainly with infusion pumps, and we do C and C++ mainly, and then there's some other stuff occasionally like Python, if you guys are familiar with that. Then in my very limited free time, I basically do open source stuff as well. I don't know how many of you are familiar with or heard of FreeDV at all. One person? Or a couple people? So I'm one of the primary maintainers on the FreeDV project now. We just came out with 2.0. I know it's not a FreeDV presentation, but we just came out with 2.0, officially. So if you want to give it a try, go ahead and give it a try after this talk.
What's it called?
FreeDV.
No, after that.
Oh, version 2.0.
In 10 months or less, what is Fusion?
So think like GameRD Star Fusion, but on HF. That's basically what it is. And we just came out with a new machine learning thing that makes the voice quality sound a lot better. Sounds a lot closer to what sideband would sound like.
Is that digital on HF?
Yes. Yeah.
Is there a website you want to share?
Yeah. FreeDV.org. Since it wasn't a FreeDV talk, I didn't put the URL for it on there.
Okay.
But basically, FreeDV.org. And then there's download links and a whole bunch of more information about it if you guys are interested. So basically, have you guys done much in terms of building your own radios, that sort of thing, like homebrew?
Long time ago, right?
Yeah.
So kind of a little bit familiar with how radios, the general building blocks. So basically, for those who aren't as familiar, usually what goes on in a traditional radio is there's several components. There's the RF component and what's known as intermediate frequency, and then whatever is basically whatever you're hearing, audio frequencies, that sort of thing. So usually how a traditional radio works is we take the RF signal at say 20 meters, for example, and we down convert it to a frequency that's a lot easier to deal with. For instance, it's a lot harder to deal come up with something that some sort of hardware that behaves well directly at 14 megahertz. So we end up down converting 14 to say, I forget what the common intermediate frequencies are, but it's usually
455.
455. Yeah. Thank you.
That's old time. That's what we used to do 50 years ago. Yeah, it was 4 ways.
And that down conversion usually happens with a local oscillator and mixer that basically generate that signal, and then and of course, as you guys probably know, it's not really just that 455 megahertz. It's there's 455 and then some other products and that sort of thing. So then you end up having to filter all that out, so you only have the 455 to deal with. And since it is at a lower frequency, it's a lot easier to deal with filter-wise. And then then you have whatever is demodulating. So like you have hardware to say demodulate like sideband or AM, FM, for example, and then that ends up pulling out over a speaker, for example. So transmit kind of works like in reverse. So you have like an oscillator and like say whatever audio or other signal you're transmitting, and it's basically combined into going back up to your intermediate frequency. And then we have other stuff that goes from intermediate, usually via VFO in the mixer, to go up from your intermediate frequency back up to say 20 meters, for example. And then even then, it's still, the signal level from doing that is still pretty low. So what you end up having to do is you have a bunch of amplifier stages to go from milliwatts up to say 100 watts, for example. So the difference between a traditional radio and an SDR is you're basically cutting out a lot of the hardware you would traditionally use on a traditional radio. So typically in an SDR, you have the RF stage still, and then you usually either can switch down to the intermediate frequency before feeding it into your computer, for example, or there are a lot of SDRs now that just operate directly off the whatever frequency you're tuned to. So like technology with SDRs, we've gotten to the point where it is actually possible to just receive directly at the RF frequency and get reasonable performance. And the way that the audio, the signal usually comes into your computer is normal analog digital converter. If you guys are familiar with like electronic type stuff, like basically ADC just turns like an analog signal into like ones and zeros to for your computer to deal with. So once it's in your whatever software you're running, you sometimes on your own computer, sometimes a lot of these days, like basically like an FPGA or some other firmware on the actual radio itself. The signal that it actually gets and that it operates on is what's known as an IQ signal. And I means that it's an in-phase signal, and Q means it's a quadrature signal. And I don't pretend to know enough about the math to even be able to like fully describe it, but basically the I and the Q are effectively sine waves that are about 90 degrees out of phase from each other. And it turns out if you have that sort of info, then you can actually demodulate a lot of the types of waveforms that we're currently using today. And as I was mentioning, the original SDRs were basically just plugged into your PC sound card. You had software running on your PC. But because technology goes on, nowadays a lot of the modern SDRs basically do processing on the radio itself. So your computer or whatever you use in Access is kind of like a front end more than anything else. So I kind of touched into what like one of the advantages of a software-defined radio. Basically, there's a lot less hardware to deal with. So, and since a lot of it is in software, so what you end up doing is you can either offer the same amount of performance as a traditional radio for cheaper, or you can charge the same amount of money for a traditional radio and have like higher quality radio effectively. And like regardless, like a lot of the SDRs I'll go into a little bit are actually fairly inexpensive now. So you can actually get into it pretty cheaply if you like. You can also, like, since a lot of it is software, you can actually more easily modify the radio to like decode something new, for example. And that's useful because then you don't have to like wait for ICOM or Yaesu or whatever to come out with a radio that can handle the newest mode that's out there. You can pretty much just theoretically just download software and new firmware to flash on your radio and get that mode or whatever you want to run with. So you can also, a lot of SDRs are actually able to receive a lot of spectrum at once, as we're talking about with the interference on VHF and UHF. Various SDRs can receive multiple megahertz of spectrum at once. Obviously, you're not really good. If you try to listen to all, like, demodulate and listen to all, like, 100 whatever, or 2 megahertz or whatever it is, the spectrum, you're not going to understand any of it. But, like, basically, you can take that, you can visualize what's going on that slice of spectrum and like a waterfall view, kind of similar to what you would, if you've ever used like a digital app like W6TX or anything like that, you can visualize it similar to that. And then of course, the amount of spectrum you can actually visualize varies based on the price. Basically, more you're willing to spend, the more spectrum you can receive at a time. So I talked a little bit about new functionality. So the screenshot that I have up here is from an SDR program called Quiz. And
Called what?
Quiz, Q-I-S-K. So you might have noticed that there's this little button right there called FDVU. And what that basically is I was talking about FreeDV a lot. That's basically a FreeDV. So the Quisk software actually has FreeDV support built in. So from your perspective, using FreeDV is simply just like using sideband or AM, for example. You don't necessarily have to download the FreeDV software if you're already running Quisk, for example. And that shows like the promise of like how SDRs can like let you keep it and keep doing like the newest possible stuff out there without having to put a lot of time and effort into it. Oh, awesome. Make sure I don't blind myself with this. There we go.
But you can use Quisk for transmit and receive?
Yes.
Is that freeware?
Yeah, it's free. I think this is running on Linux. I think you can run it on other platforms, but I haven't really. I mostly run on Mac and Linux, so I don't have too much experience trying to run it on Windows. But I think theoretically you can. And then another. I promise I'm going to stop talking about FreeDV. But basically another. I have an example of like another like thing that SDRs basically enable you to do. This is called an EasyDV, and what this basically is, it's an ESP32 based device, and that can decode and encode FreeDV, and it also has support for connecting to the Flex 6000, 8000 series, soon to be Aurora series as well.
Really?
Mm-hmm. Huh. And when you configure it and you like to connect to your radio over your home network, what it'll basically do is it'll connect to your radio, and in the Smart SDR software or Maestro or whatever you're using to communicate with your Flex, it basically just kind of similar to like what Quisk had, where it just shows up as like a separate mode, like FDVU or an FDVL. So just like with Quisk, it ends up behaving pretty similarly, like say if you were just wanting to operate sideband, for example.
The Flex, they have a Flex version that's 9600. That's actually commercial. It's a commercial HF radio, and it can do ALE 2G, 3G, and they say 4G. I haven't seen a 4G ALE radio yet, but they say they have one. But if they don't have digital voice, and digital voice is a really big deal now in the commercial HF world. So this might be, it'd be interesting to test your digital voice out with like a Kodan or a Barrett digital voice to see if they're compatible.
So not exactly the point of this, but like I can tell you right now that like FreeDV is kind of its own thing that's not really like going to be able to interoperate with like say like Kodan or anything like that. But like there's a lot more information on the FreeDV website, and there's like papers and stuff, and you can see how well it performs versus sideband and like what we've done in the past.
Does it I'm sorry, I know this is a relief, but you triggered something in here. Does it auto baud for your throughput for the digital voice, or is it set at like 600 kilobaud or something like that?
So the older FreeDV stuff we've had was basically it had fixed baud rates and like multiple modes, but it didn't really auto baud, so you had to like know which mode to choose based on what band conditions. The new 2.0 we just came out with like a couple days ago, literally, uses a basically different modulation where it's kind of similar to analog PSK. So and since there is like machine learning type stuff involved, it helps like decode those analog PSK signals that come out over the air. So like even if the band is not really that great, it can actually decode down pretty low. with the same sort of like amount of data that's coming over effectively. And answer? Awesome. All right. So yeah, as I was saying, this board basically connects to your radio, your Flex radio, also the 705, but the 705 unfortunately doesn't let you like create an FDVU button on your 705, for example. So just like with Quisk, the Flex will just create like a FDVU and FDVL mode button. And if you're interested in playing around with this, it's not going to support the new mode I was talking about. But like if you want to just have technology to play with, and or even just like a ESP32 that you can do whatever you want, and flash whatever firmware you want, talk to Tapper. They have a bunch of these. So there's actually a lot of things to consider when you're talking about software-defined radios. Basically, some questions you got to ask yourself before, like, to decide what kind of radio you want to buy. As I was mentioning before, like, one consideration is like how much bandwidth you want to be able to receive at once. The cheapest SDRs kind of like are constrained to about the bandwidth of like the normal sound card, like 48 kilohertz or so. But you can go up to like multiple megahertz. And in a little bit, I'm going to talk about like the couple radios that I have experience with, and you can see the compare and contrast the differences between them. And as I was also mentioning, the more features you have in your radio, the more it costs. Like SDRs don't necessarily get you around that, unfortunately. There's also different SDRs, whether you want to you're just fine with something that can only receive, or if you want to be able to transmit as well. Of course, receive only tends to be a lot cheaper than something that's able to transmit. And then, depending on the SDR, you can have a varying number of effectively VFOs. A lot of the common SDRs are about 1 to 2 slices or VFOs, but there are some like the higher end Flex radios, for example, that can do like 4 slices at once. So you can receive 4 different. You can basically have, for example, like 3 different digital programs running, and like decoding digital modes on HF, for example, and maybe your last one is decoding like a normal sideband conversation. And again, like depending on how many slices you're going to be able to receive, like you can spend a fair amount of money doing that. There's also a concept of bits. I talked a little bit about analog to digital converters before. So the bits is what that refers to, like, and depending on the number of bits in the analog digital converter that your SDR uses, it actually you can actually increase the dynamic range a fair bit. So you can actually better receive certain signals. And there's other considerations, like again, like a 12-bit AUC is going to cost more than an 8-bit one, and a lot of the cheaper ones are 8-bit. And then there's also some SDRs that you can operate standalone, like you don't need to like have a computer plugged into it, for example. Like it kind of operates pretty similarly to like a normal traditional radio, like with actual dials and everything. But like a lot of especially the less expensive SDRs, like you need a computer to use them, and that's something to keep in mind as well. So a nice and free option, if you want to get your feet wet, is how many of you have heard of QESDR or WebSDR? So basically what these are is it's a bunch of people and they have like SDR radios plugged into their own computers at home somewhere or posted somewhere else, and they have like server software that's running on like a computer there, and people can like go visit like these in their web browser and actually listen as though they're actually right there receiving. These are receive only. That as far as I know, there's no WebSDRs or QESDRs that can transmit. And it also depends on like who's hosting that particular server, and like what their setup is. Like there's some like maybe I'll see in a bit like how well the internet's working. But like there are some where you can actually receive pretty much all of HF, and maybe there's others that maybe you only get like 1 or 2 bands. So it really depends on like what you're receiving. And let me see if I can get this working. I was trying to see if I can test the audio, but You guys are all talking, so let's see if how well this audio. Well, let's see how well the internet works first, because this might fall. This is part of the presentation I didn't plan on, so this might fall flat. Can you hear it from the projector? Okay. So basically, what we're doing, what's on the screen right now is SDRutah.org. It's a really big web SDR site based in somewhere in northern Utah. I don't remember where. And they have like several servers with like different tenants. And you can read about their configuration and how everything's set up on their main website. But what I have here is basically I have one of their SDRs on 20 meters right now, and I have it on a frequency where there's nothing going on at the moment. So let's see if we can tune to something. So this looks like a pretty strong signal. So the nice thing about web SDR is you can just double click or like drag. And then I can spend more time and get it like right on frequency, but basically you're able to just listen to it like you were saying at home. I believe web SDR supports like upper lower sideband AM, and it might I think there's a mode button on here too. Oh yeah, it supports CW also. So if you guys are in CW, you can listen to CW over a web SDR as well. And then, as I mentioned, there's web SDR based ones and Kiwi SDR based ones. In my experience, the web SDR servers have a lot less latency, and like if you're like changing frequencies or whatever, you basically hear right away when something changes. And my experience with Kiwi SDRs, you change the frequency and it takes like a couple seconds for it to actually like kick in. So something like that you might be okay with, you might not be okay with. They might have even improved it. So since I like last week Kiwi SDR. And then another not free option, also receive only, is called the RTL SDR. How many of you have one of those, or most of the people here? So the RTL SDR is actually really cool. It's about less than $100. Less than $100 pre-tariff. I don't know how much it is now.
It's $30.
$30 now?
The V4, yeah, $30.
So it didn't sound like it went up that much. So I have I don't have a V4 photo up there, unfortunately. That's the V3 one. But the RTL SDR, at least the V3 version, can receive up to about 2 megahertz spectrum at a time. And it actually has a pretty wide frequency range. 500 kilohertz, which is about the lower end of AM broadcast, all the way up to like 1.8 gigahertz and a little beyond that as well. It's also one of the older SDRs, so it has at least the V3 version is one of the older SDRs, so it has an 8-bit ADC. I don't know if the V4 has a 12-bit.
I don't,
So yeah, but yeah, I basically just played with I think they only released the V4 recently.
Yeah, it's better on HF.
Mm-hmm. So yeah, as I mentioned, that's a V3 up there. And you probably also saw that there's a USB connection on there. This is intended for just directly plugging into your computer. You can't just put it somewhere unless you were to plug it into like a Raspberry Pi, for example. But the nice thing about the RTL SDR, having been around a while, is that there's actually a lot of software that's available that's compatible with it. I have a couple of applications just listed here. The first one is SDR Chart. It's a Windows-only one as far as I know. And then there's SDR++, which supports all the major platforms. And then LinRad also supports all the major platforms as well. I have experience just with SDR++. I think I have it installed on here. So I can show you at least what that looks like. So basically, this is, I'm sorry, the text is kind of small, but this is basically SDR++. So there's a bunch of settings on here, and like you can, that's where you would basically choose like what SDR you have plugged in, and then it's a lot of the same similar sort of settings you would have on a traditional radio, like the mode you want to use and what like your receive bandwidth is, and noise blanker as well, and basically a bunch of other stuff. And if you scroll down even further, went too far. There's like you can like record what you're hearing on the air. There's also, I believe you can like load plugins as well to decode various things. Like I remember playing with like adding an M17 plugin and was able to decode M17 with this. So it's all sorts of stuff. You could spend a really long time playing around with this to like get it just the way you want.
Any plugins for encryption yet? Decoding encryption?
Since San Diego PD just swapped.
Yeah, I mean, someone probably wrote one somewhere, but I don't know offhand. And then one thing to keep in mind, since the RTL SDR has been around a while, there's a lot of clones of the RTL SDR. So like you really have to be like really cognizant. Like if you find some like what looks like an RTL SDR and it's less than $30, then probably a clone. And if you end up getting a clone, there's like various issues that can result from that. Like a lot of the clones, they just flat out just leave out functionality. So like for instance, you buy a clone and you maybe try to receive HF or whatever, but like the components in there that would enable you to listen to HF maybe just aren't there. So then like you're trying to receive and you're wondering why is it dead, even though you know like the band's like active that day or something. And then that's when you realize you bought a clone and you got ripped off. And then there's just general like,
I was just going to say for the RTL SDR, you go to the website, they'll tell you who's selling the original, the authentic ones instead of going on to Amazon,
Yeah.
eBay, and buying a club.
That's good to know as well. And like, yeah, I think they have like an official store on there that you can just go and buy the RTL SDR straight from there if you're interested. But like you can also, sometimes they're just built pretty crappy as well. Like cheaper components or whatever, so they, for example, so they allow more noise into the receiver, so you're not receiving as well as you otherwise could have with an official one. And maybe just because they use a plastic case instead of a metal case, it just doesn't feel great, right? Stuff like that.
That thing will melt.
Yeah.
So yeah, definitely just go to the RTL SDR website and buy it from there if you're interested in this. And another really cool radio is the Hermes Light. Have you guys heard of the Hermes at all, or?
It was published in Q6AQ 5 years ago.
So the nice thing about the Hermes is that it actually it supports transmit and receive, mainly on HF. Down, I think it goes up to like 35 nanohertz or something like that for receiving transmit. Lower sensitivity above like 10 meters. So it goes up high enough that you can plug a transmitter in, for example, and conceivably go on 2 meter or 7 centimeter, for example. It also has 12-bit ABC instead of like with the RTL SDR. And with that, it can actually receive up to about 300 kilohertz of spectrum at a time. So it's wide enough for most HF bands pretty much. And it's also a really nice thing about the Hermes is that least expensive radio that can, SDR radio that I'm going to be talking about tonight that can do transmit and receive. I put the price up here as $300. Again, I think this is pre-tariff pricing, because if we do try to order the Hermes, it'll come from China. So who knows if it's still going to be $300 by the time it gets to your door. I figured I'd put that out there. The other cool thing with the Hermes is that since it is another radio that's been out for a while, and it is pretty extensible and open source and open hardware, there are a lot of people who have built like various extensions and add-ons for it. For example, like there's a board you can get and build and put on the back of this that gives you basically a serial port, and you can plug it into amplifiers that support it. Like for example, I plugged for the longest time before I started using the Flex. I was using a Hermes and a Hard Rock amplifier as my home setup. So I basically plugged the Hard Rock into my Hermes, and whenever I would open up the SDR software and change bands and stuff, it would actually reflect on the Hard Rock as well without me having to push buttons. And likewise, whenever I would transmit, the Hard Rock would know to go into transmit. So it basically controlled all that automatically for me, which is really nice. There's also another board you can buy and build and install, which adds effectively a third receive port. And what you can do with that third receive port is go in and enable what's known as adaptive pre-distortion. I'm sure you guys heard about the Flex's announcement of like the 8000 series and how they're doing adaptive pre-distortion. So basically you can do the same thing with the Hermes for about a tenth of the money. It's called Pure Signal in the various SDR programs that support it. And it works pretty similarly to how it would work on the Flex, where it taps into the signal and adjusts the signal so that you're not distorting as badly. And then, unlike with the RTL SDR, this actually connects to your network over Ethernet. So there's an Ethernet port that's on the front of this. You just plug it into your switch or your router. You can also just plug it straight into your computer if you're, say, wanting to take the Hermes portable, and the Hermes runs on 12 volts, so you can easily plug a battery into it if you like. And since the Hermes has also been around a while, there's a lot of software support for it. For instance, PyHB SDR, which is what I usually use on Mac. I believe it was originally written for I think it was written for the Happy Labs, or I think. I might be mixing that up, but it was written for another radio at some point, but someone who modified it to work on the Hermes. There's also Quisp, which I showed you earlier in the presentation. And then if you're into Windows, the two most common programs that people use are Power SDR and Thetis. People seem to be trending more towards Thetis because that's more actively maintained. And I don't have much experience with either of those, but I've heard from other people that Thetis actually does a pretty good job. And then the most expensive radio we're going to be talking about today is the Flex 6000, 8000 Aurora series. They're kind of in the same sort of ballpark. They also support both transmit and receive, but instead of only, I forgot to mention with the Hermes, the transmit is QRP power, so only about 5 watts or so. The Flex radios can transmit from 100 watts up to 500 with the Aurora they just announced. And it can do HF and 6 meters. And depending on the model you get, you can receive up to 7 or 14 megahertz spectrum at a time, 2 to 4 slices. And the default Flex radio, if you were to buy an 84 or 8600 series today, basically doesn't have a screen on it. You would need to plug it in your computer. But you can also get an optional display called a Maestro, and that also plugs into your network, and you can tune it, play with it as though it was a normal radio. There's also versions of it where that Maestro is basically just built into the radio, so it kind of just looks like a normal radio, just with like a big color screen, effectively. And of course, you're going to be paying for the privilege of that. I think it starts off at like $2,000, $3,000, and goes up from there. So kind of like a fancy new computer to start with. So, but as someone who owns a 6300, I'm used to my gear. I feel like it's a pretty good radio. But if you're gonna get a version that doesn't have a display, then you will need to use unlike with the other radios where you have multiple software options, you're basically stuck using the Smart SDR software effectively. And that's available on Mac, Linux, or Mac and Windows. And I believe it's available on iOS as well for like your iPhone or iPad. Someone also wrote a third-party program a set of programs called NDAX and NCAT for Linux. And what that basically does is it implements about 2/3 of what Smart SDR would do. So like say if you want to run like WHATX on your Raspberry Pi, then you can run NDAX and CAT, and it will connect to your radio, and they'll give you CAT control and like virtual audio effectively. And I've used NDAX and CAT before, and it actually works pretty well.
You know if Quisp will run on a higher Pi 0?
I think it will.
Even on a Pi 0?
I don't know about a 0. It will on the 3, 4, 5 or whatever. Um, and then another nice thing about the Flex radios is that they were built pretty much for remote software from the start, remote operation rather. So they have something called SmartLink where your radio basically just connects to the cloud, or the Flex's cloud, or wherever it's hosted at. And when you have Smart SDR installed on your computer, if it detects you're not on the same network as your radio, then it'll show that you're connecting via SmartLink. So it basically goes out to the cloud and connects to your radio that way. And it operates just as though you were in front of the radio. Plus, minus some latency, of course, depending on what kind of internet connection you have and that sort of thing. But it is pretty well optimized, so you can actually use a cell phone hotspot, for example. And I've done that before with pretty good results. There's also, if you guys, who here does software development besides me? A couple people. So if you're interested in like writing some software for the Flex, they have a public API available, GitHub.com, Flex Radio, and so like basically it's a like what protocol they're using, what commands you can send to the radio over the network to do whatever you want it to do. And that's the API that the EasyDB device that I talked about earlier uses as well to enable the new modes showing up on the Smart SDR application. And that's, I'm pretty sure that's also what like NDAX and NCAT author are using to connect to the radio as well. And then before we go on to since we're talking about software right now, I'm going to go ahead and the internet was working earlier tonight, so we'll see. I'm going to try to connect to my home radio and see how it goes. So as you saw, you probably went by a little bit quick, but it said like SmartLink because I'm not on the same port as my radio. And right now we are connected to my radio at home. So 20 meters is actually doing pretty well right now.
Yeah.
So I can actually, I'm going to go ahead and, so we're going to try to receive that pretty strong signal. So I'm going to go ahead and change it from Digi because I was using digital modes earlier. Just a normal sideband. Hang on. This is the part where it goes south. Here. There we go. So yeah, basically just operates just as though I was sitting in front of the radio at home.
Are there any examples of 3DG?
I can see if hang on. I don't. So our free TV frequency is normally 1436. It doesn't look like I'm receiving anyone there right now. But if you guys are interested, I can like pull up the application right now. You can hear what it sounds like. But maybe I can do that after we do questions and answers for the main presentation. So yeah, basically it just operates as though normal radio at home. And then like you can zoom out. It looks like my neighbor turned off their, well, I don't think they turned off their air conditioner, but I think the noise floor got better. I was talking earlier about like how my neighbor just got in a new air conditioner and basically just made 17 meters useless and 20 meters harder, depending on the time of day. You can kind of see the signal, the RFI from the air conditioner, like the pulsing type stuff. Unfortunately, I don't know my neighbor well enough to like bring it up with them. So,
But when it shuts off, that goes flat.
no, the thing is that it's on always.
Oh,
It's just it depends on the time of day. Like sometimes it's like pretty, you can barely see it, and sometimes it's you can see it pretty strongly, like you can like right now. I did kind of an aside. I spent like a while on the roof for our condo building, like rotating the MFJ mag loop that I have up there to try to mill it out and that sort of thing. And I actually got it to where 20 meters is fine most of the time, but obviously not quite fine right now. So I'll have to, when I get more time, I'll have to like go up there again and see if I can. I might have to go up there at night and do it like that because during the day I got it actually okay, but like problem is not working. I can't really operate from work. But yeah, that kind of gives you an idea of what you can do with Smart SDR, pretty much.
Do you have a lot of solar panels in your?
So I'm fortunate in that So the building that I live in has it's just condos. It's all condos from like the 80s and whatever. So the HOA never bothered putting solar, and not, as far as I know, none of the units in our complex bothered getting solar. Even though I guess apparently condo solar is possible. As like the person at Costco who's trying to sell us solar panels told me, because I would go to like they would Sunrunner and whoever it is would be like, oh, you're interested in solar? And I'd always be like, oh no, we live in a condo. And they're like, oh no, we can still do it. And I'm like, oh. I should just tell my rent next time, so they'll leave me alone.
That is a really big issue for HF. Some of the older inverters, inverters will cause a lot of hash and trash on HF.
My parents last time I went and brought my portable radio stuff and tried to operate at my parents' house. Their neighbor got a solar thing on there, and I'm pretty sure that's what I'm seeing on 20 meters during the day because it goes away at night. So
LED TV.
It's when they convert it to AC on the roof, and then it acts as a big antenna and it radiates.
At the
But if you use DC and convert it down below, because it all comes down in conduit, there's no problem. But the DC system's gone away. They're all AC.
like you might be able to build your own DC system, but like I feel like you probably would be on your own on that because like the solar people want to sell you the microinverter stuff, right?
Yeah.
Now they put solar at the state operations center in Maida, California, for the state Office of Emergency Services, and so for a long time we didn't have any problems with the HF receivers, and then they had one fail, and some guy came in and did something, probably replaced something, and now it's trapping the HF radio pretty bad. So much so they're having to use SDRs to monitor for the nets.
Yeah. Which is problematic on its own if the power goes out or internet goes out, right?
Exactly. Right. Negates the whole picture.
So, and then I have another thing I can go into about like the emergency agencies who are just deciding that they want to go with Starlink instead of like Aries or whatever. But that's a totally different, that's like a totally different conversation for after this. So I kind of showed you a little bit when I was demoing the various programs. Most SDR programs out there will do some sort of auto detection. So like if your radio is plugged into the Ethernet, for example, they typically send a broadcast packet out over your network every like second or two. And if you turn on your SDR program of choice, it will listen for that packet, and like when it sees it, it'll show you your radio and its IP address as like an option you can choose. And then if it's a radio like the RTL SDR that plugs straight into your network, then typically it'll just enumerate for all of your USB devices that are plugged into your computer, and it'll look for specific USB IDs that correspond to like SDRs that it knows about, and that's how it'll show like what radios you have available. And that usually is enough to get you like started. There is extra configuration, as you saw with the SDR++ program, where you can go through and set up a lot of other stuff. But the most important thing is probably when you set up like what speaker and microphone you're using, or speaker and or microphone you're using, so you can actually hear what you're receiving. And then if you're using a digital, like if you want to plug FT8 into it and receive and transmit FT8, for example, you'll need something called a virtual audio cable typically. And on Windows, you typically have the choice of VB cable or a virtual audio cable. Mac also has VB cable available. So VB cable is what's known as donationware, where you can just download it for free, but really good idea to just donate the money to the guy who wrote it. And if you do, you get like an extra like couple audio cables that you can install, and it'll show up as separate like audio devices on the computer. Definitely useful if you're gonna have like multiple slices, for example. And once you have a virtual audio cable set up, you would choose that virtual audio cable in your program settings instead of USB audio codec or whatever you would normally use. And a lot of SDR programs also will generate a virtual serial port, and that's what you would provide when you're setting up cat control in your own whatever program you're using. And there are some digital programs that also can do what's known as TCP/IP cat control. Instead of just instead of telling the program to connect to like a virtual COM port, like COM4 or whatever, you would you would tell it to like connect on local host to a specific port, and it basically acts the same as though you were using a regular COM port, and it's actually pretty useful. So you don't have to deal with like setting up multiple drivers, just the driver for your audio, pretty much. And then that's pretty much it for the slides that I have. I know I was going through questions at the beginning of during the presentation. If I don't end up answering your question, you can always email me, mooneer@gmail.com. And if you want to hang out with other 3DB users or find me on Discord, QR code's right there. The Mind is Watching with my call sign on. I believe my call sign's attached to my name on Discord as well, so you can find me there. And then open up for a little bit of questions, and then maybe we can. I know someone wanted to hear a demo of what 3DB sounds like, so maybe if we have time after, we can do that.
Do you have these slides on website? Or on your
I don't have them uploaded anywhere, but if I can give them to you guys, I can
That'd be
upload.
great, yeah.
You guys can put them on your website or something.
Okay.
So you were talking about the microphone. Obviously, like, say you wanted to transmit from here on your Flex.
Mm-hmm.
How would you do the mic part of it?
So I'll pull up some SDR again so I can show you.
Can you plug in like a USB mic
Yeah, I mean,
and like pipe the audio over the network? Somehow,
that's
like push to talk, like that.
Yeah.
You got a lot of things.
So right now I have I have Smart SDR on my laptop set up, so that the speaker is the projector.
Right.
And then I'm just using the built-in microphone on my laptop.
Yeah. Okay. So you just it's.
But like if it shows up in your operating system as like a microphone or a speaker, you can choose it.
Yeah. So but where's like the push to talk button? Like
Oh, yeah.
is it like a button on the screen, and then
Yeah.
you just
So
stick into the.
let's connect to the radio again, and I'll show you.
Is
I think spacebar works on Smart
Okay.
SDR.
Yeah. Like.
But like there's also a Mox button up there,
Ah, gotcha. Okay.
and you can push that and.
So is it the same thing kind of with the Hermes Light, where it's like?
Yeah, I think it's called Mox on the SDR programs that the Hermes supports too.
Gotcha. Okay.
So that might be a standard thing that they call it.
Can you use like Bluetooth push-to-talk mics? Like Baofeng makes them, for example. They're like little Bluetooth push-to-talks.
You might be able to. I've never tried it, so I can't tell you for sure.
Yeah. I don't see what a.
Yeah, I mean, like if you, like I've paired Bluetooth devices in my computer before, and they show up as like another speaker or headset or whatever. So I know the audio part works. I don't know about the push-to-talk part. Any other? Okay. Let's see if I can make this work. I can show you we can quickly demo what 3DB sounds like. So
Your QRP Labs makes a SDR radio transceiver 63160.
is that it's not
QMX
QMX
Plus.
Oh yeah.
And this is the QMX here, and it'll do sideband now as well.
Yeah, I have a normal QMX.
Okay.
I put the SSB firmware on it. I actually used it to connect with WinLink once.
Okay.
And then I tried to use it again recently at that Aries activity day.
Yeah.
And when I plugged it in and got everything set up, I had like basically no audio coming into my computer. So I Googled a little bit on it, and I think it might be a hardware problem. So that I don't have, when I get more time, I'll have to like investigate more, because I've already had to do SMD replacements on it. So
I'm
like
just wondering if it'll run free DV.
it should. I mean, with the new sideband firmware, it should. Before they came out with the sideband firmware, you wouldn't have been able to because it's a single tone, right? So this is what 3DB looks like for those of you curious. Let me make sure my audio settings are all correct. Here, I'll put it through the projector.
QRP Lab radio is pretty inexpensive.
So yeah, here's an example of what I mean with the cat control. So I have handlers set up on here, and I basically told it to use the Flex 2000 series, and I'm connecting the localhost 5001, which is what the smart SDR software is listening on. So if I go ahead and push start, and I'll see if this works.
Is 3dB typically only used on 20 meter, or is it?
There's other frequencies as well. There's a thing on the website. So this is basically a waterfall display, and right now this is band noise. But like I can, I have a sample file I can play to like demo what this sounds like. Can you hear it? All right. If not, I can put it on my normal speakers instead.
How many bit? 8 bit?
It's kind of hard to say what kind of bits per second the 3dB can do. Because the way that the modulation works is just analog to scale. So this is that new mode that I was talking about.
I don't know the recording, so I do that. Yes, like, I don't know if necessarily anything has to be done. Exactly.
As I mentioned, there's like a whole page around how it works and everything. So that's basically what I'm here. I'm gonna just put it on my normal speakers because I can barely hear it.
Yeah.
So
A lot of background.
Is this the one with the machine learning audio enhancement?
yeah. I'm gonna change my audio settings so I have access to the volume control.
Yeah, okay. Well, I don't know.
So this guy that I was talking to is in St. Louis, Missouri,
seem to be pretty
and
good.
you can see that
That's
that day that I
difficult to
recorded
talk
this,
to, that's for
like,
sure.
waiting like stuff.
Signals are changing a lot, down to nothing. So
So
doing a
he
pretty
still
good
sounds
job
like
with
he
it,
does in real life,
I would say.
even with all that.
Hopefully, well, he's copy with
What kind
Ryan
of bandwidth does it take up?
It's about 1.5 kilohertz wide.
Oh, so like they're like half the size.
Yeah.
But going on another trip that day.
And what is that coming down now, that interference?
Just doesn't work out.
So this is
On the right and left side of the center.
oh that's
Walter, be there was somebody.
I don't know if I don't think that's sideband. I think that's just
And I'm
like
sure other people would.
I don't know what that is exactly. So
Just a long time ago.
So where was this guy that you're talking to?
St. Louis.
St. Louis. And was the band conditions good that day?
They were okay. Like you could see there was a lot of fading and stuff.
Oh yeah.
There's another recording that I have where we were transmitting analog in 3dB. He couldn't hear me at all. But with 3dB, like I was coming in loud and clear.
So is it a good low
Yeah,
power?
unfortunately.
I think so.
Yeah, so on have you tried it on like QRP power?
What's up?
To see how well you can do QRP compared to like.
There's people who have. There's people who
100.
have. There's people who've transmitted down to like 1 or 2 watts, and it was still coming in pretty good.
Yeah. Have you seen a big adoption of it?
So we just came out with a new version a couple days ago. Let me pull up the. We have a spotting service called 3D Reporter. Actually, the web-based version was probably going to be easier to see. So basically, this 3D Reporter page has been basically full the entire time since we came out with a new one. So it's gotten a lot more adoption, especially in the last couple of days. So if you tried 3DB a long time ago and like you didn't like it or anything, definitely give it another shot.
Yeah, I think I tried it years ago, and it was pretty garbled. But
Yeah.
then again, I think my settings were wrong or something. But wow.
So yeah, there's a lot of Japanese stations because it's that time of night.
Yeah.
But yeah, like and then there's a chat view as well, so you can chat with people that way.
So if you can do voice, can you do FTA?
On the like
Through like I know it's like like a digital mode through free DV.
Oh, there's something called free data, and it's kind of similar to. It kind of works like bar AC,
Yeah.
where like it uses like the older modulation that FreeDV use, and it uses that to transfer files and do chat and stuff.
Oh.
So yeah, any Oh,
Where can I get information on how the machine learning enhances the audio?
so
Like the algorithms, the training?
yeah, so let me see if I can. Let me see if I can find the. I know it was just. Oh, this latest blog post right there has the paper.
Oh, fantastic.
So you can just click on the and there's a PDF link. You can read all about how it actually works.
So this is Windows and Mac.
Windows, Mac, and Linux.
So is there an image for Raspberry Pi? So you can do Linux.
There's some guy in the UK wrote a build script, and you can just clone that on GitHub and just run the build script and it'll auto build.
Okay.
I don't think there's any there's 3DB packages for like distros and stuff, but they're not the.
Oh, okay.
So if you try to download one of those packages, you're not going to have the latest stuff we've been doing.
So that run on the Windows package, on the Windows tab, it's not true Windows, it's like a hybrid version. And what is CE at that?
Oh, I know what you're talking about, like the S mode. Is it S
Yeah,
mode one?
something like that, yeah.
So you probably would need to unlock your computer to get out of S mode.
Okay.
Because it's a normal Windows application. It's not like a universal Windows, like whatever they call them, the Microsoft Store stuff.
Okay.
So the free data project. What was that other project that was for like a digital mode that uses free DV?
It's freedata.org.
Okay.
They have like programs you can download that basically do that, and I know there's a fair bit of activity there too.
It's a separate project?
Yeah, separate project. Separate project, but we share the same like backend code pretty much.
Right. And it's locked on certain frequencies, right? 14.236 and
I mean,
40
you
meters
can,
has one.
So those are calling frequencies. Like
Yeah.
there's
So
nothing
that's
stopping
where-
you from like choosing another frequency on
right.
the band, right?
But you're gonna find the most traffic on that,
yeah,
right?
like 14.236 is the most common one.
Yeah.
There's like others for various bands,
Yeah.
and some of these are basically frequencies designed for like different, not US. So you might not necessarily be able to operate on some of these.
Yeah.
But like for example, 3DV is not legal on 60 here.
Yeah.
But like it gives you an idea of where to look for. You can also pull up the 3DV reporter, and you can see what people are doing, like where they are at any given time. So that's useful for finding contacts.
And that's self-spotting, right?
No, like
Or does it pick you up based on what you put in the app and it like auto reports you?
so like basically when you go and set up so when you first download 3DV, you'll see basically this window.
Yeah.
You put your call sign and root square
Right,
on there,
yeah.
and if it has internet, when you push the start button, it will connect.
That's cool.
You'll connect on there, and then if it's able to decode a signal, you can see right now LU2 EP is transmitting.
Yeah.
And this is a live status. So like, if someone were receiving LU2 EP right now, they would show a blue background.
Gotcha.
Like pretty much immediately after they start transmitting, right? I'm sorry I derailed this with 3DV. Any other questions?
Have you played with there's in fact the SDRs, there's one that can see a huge swath of HF. It's called Web 888 or something like that.
I haven't heard of that
And
one.
it's like, I think it has multi-port antenna ports, but like, it's the biggest one I've seen that can see all of HF at once, basically.
There's a project by Phil Karn, K6AQ. He has something where it basically receives like all of VHF and UHF and like all that.
I just
at
saw
once.
that. That was
Yeah.
pretty impressive.
Is that correct?
No.
An SDR?
No, that's directional finding.
Yeah.
But yeah, like I think I don't know like if like he would be like a better person. Phil Kern would be a better person to talk to about that particular project.
Yeah,
Like,
he's going to speak about that too. We've talked to him. I was at the ham luncheon last week, and he demonstrated it to me. It's amazing, and he archives all the audio of all the bands. He just has a system that just records 24/7, so he can go back at any time on any band and like play back what was transmitting. It's very impressive.
Yeah, I'm just thinking that.
Yeah.
Oh, something I didn't get to show in this presentation. I don't know if so here I'm gonna find. So Phil Karn has a Kiwi SDR as well.
Yeah.
I need
use
to.
it. I use that one all
Hang
the
on,
time.
I'm gonna try to mute it.
Yeah.
That way I can check if my.
So I don't know if this one has it, but some of the Kiwi SDRs. Oh, this one might not have it, but there's some of the Kiwi SDRs have a thing on here where it can connect multiple Kiwi SDRs together and like do direction finding. That's what that reminded me of.
Oh.
Huh.
So like it will tell you, it will show on the map approximately where it thinks it's really hot. So useful for finding people who are interfering.
Something else the FCC would like, huh?
Yeah. Very cool.
Anything else?
Nope. Thank you.
Thank you, my man. Thank you.
Thank you.
Thank you for having me.